By solid geometry, we're going to study. This is the second lesson, and after that, no more geometry. Okay. This is a second lesson on geometry, on solid geometry. It's called 3D geometry. Okay. The reason it's put in the last part is it requires the knowledge we already learned, about circles, okay, about Pythagorean theory. We use that for the information. So today we are going to talk about in the last class we studied cylinders, rectangle box, prisms. But this time we're going to study cones and spheres. Cones or cone-like, when you're talking about cone, usually mean a circular cone because there are cones in many different forms, okay? A cone is, you have a two-dimensional region, a domain, okay? And then as a point in the space, you connect all the lines and that's called the cone. Okay, that's the definition of the cone, okay? It's all the cone-like solid. So for a cone, how to find the volume? And mathematicians find out the formula already. If the base area is A, and if we know the height, okay, this is the height, then the volume is going to be the base area times height. If, of course, this is going to be the area, the volume of the cylinder above this above this region in the two-dimensional plane. Okay, but you have to divide by 3. I check 1/3. I'm surprised. Yeah. So in other words, for example, the circular cylinder, circular cone. This is a circular cylinder, a typical point, and this is a cone inside, right? So if this is height, if the radius is r, right, then the area of volume for the cylinder will be the volume of the cylinder is going to be base area times height. Okay, A times height. But for the cone, it is going to be base area times height divided by 3. So the cone only occupies 1/3 of the volume of the cylinder. Okay, 1/3 of the volume. 1/3 of the volume of the cylinder. So that's this is it is proved using I think using advanced mathematics. You cannot do that. You cannot prove that using elementary mathematics. Okay, you have to, the following formulas we're going to study here, you cannot prove that using elementary mathematics. You have to take the calculus 1 or 2 in order to get a proof. Okay, so we just accept those formulas. We're going to use it. Another formula is for the volume of the sphere. Okay, for the volume of the sphere imagine, so first of all, the sphere with radius r, the surface area, okay, is going to be 4 pi r squared. Okay. Now you can also view the sphere as some kind of a cone, but this time the base is the sphere, not like a flat circle. So it is going to be like a, from the center to all sides, right? So the volume is going to be actually 1/3 of the area times r. Okay, so which is going to be it's a 4 pi r squared times r cubed. So it's not a surprise there will be 1/3 there because you can view the sphere in like a cone over as a ball, as a cone over the sphere. Okay, Karen, sit here. Okay. All right, so this is what we should know. Okay, this is and how to get the area for the sphere, surface of the sphere. That still need advanced mathematics. You cannot do that. That's the reason we have to study more mathematics in order to solve formulas, solve the problems in elementary mathematics. And the student who took calculus, they also asking me, hey, what is beyond the calculus? Okay, and why we have to learn more? Because there are more complicated problems. You need more. Calculus is not enough. Calculus is just a tool to study those problems. It's such like a flow mechanics. Understand the blood flow in the vessel in the body, and when you design a device to pump the heart, right? Then you have to understand the flow mechanics. Then the calculus is not enough. Okay, and if you become an engineer without a very weak mathematics, you are not able to help work with a scientist to design such pumps, right? So do need more advanced mathematics to understand the flow mechanics. Even like an airplane, you heard about the sad story, right? The Boeing 737. And this kind of airplane design without mathematics, deep math, not beyond the calculus. You cannot do that. Okay? It's very hard to design base the shape of the airplane, so the resistance is minimal. This kind of things. Okay, it's belong to the flow mechanics. Of course, the electronic mechanics must be involved because inside the airplane, there's so many wires. If you look inside, it's too complicated. Even you open your computers, you can understand what's going inside, right? Okay, so those are the basic formulas. And yeah, if you had a chance to go to Dayton, there's a museum, right? And I saw, if there's some older, even older space shuttle, if they open it, and when you look at inside, it's so complicated. It's hard to understand why there are so many tubes, wines, inside, right? It's very complicated. So some of them do need the mathematics to understand, okay? And so even you want to study engineering in the future, okay? All right, so let's do the first problem, okay? We have a triangle, okay? Let me draw the triangle first. Yeah, on the base side, we have a triangle, okay? So you have A, B, C. This is it's a 5, and here it's going to be 12, and here's 13. So I have another point in the space, okay? This is the point. Now let me draw the point here. So I connect them. So I get, this is a cone, okay? You can call the pyramid. You can call the triangular pyramid. Most of pyramid is, the base is a square, or could be rectangle. But this can be a triangle, okay? You can still go inside, stay inside, right? If you build it like that. So what do we have here? We know the height. I measure the height. So that's easy problem, right? Measure the height. H is going to be 10. Find the volume. That's easy. But if I ask you to find the surface area of this called tetrahedron, okay, then it's very challenging. Okay, it's not easy to figure it out. So we will do some problems like this later. So find the volume. The volume, it says that 1/3 the base area. Write on the formula you're going to use. Okay, you have to have this kind of habit. Write on the formula that you use, because when you get to the college, okay, the math problems will be complicated. Sometimes it takes 1 page, not just a couple lines to finish it. But without mentioning the key ideas at the very beginning, you are going to lose more credits if the answer is wrong. Okay? Okay, don't just focus on the answer. You have to focus on details. Let me repeat again. When you do the homework, you know, your parents already print out the homework assignment. So yes, there is a space you can put the answer there. But you do have to, on a separate paper, okay? And you have to work out the details. You don't need to copy the problem, but you have to draw the picture for each geometry problem. And Brian, shut up. Okay, so you can, yeah, you have to write down, show the steps and how much you have to show. Look at my lecture notes, how much I put there. That's what you have to do. You have to learn. Okay, so this is one of the purpose taking the course, not to just learn the knowledge. Okay. All right. So question: how do you, the height is already given? I have to find the base. So base is a triangle, and that's a special triangle. You notice that 5 square plus 12 square equals 13 square. So this is the right triangle. So the area is going to be half of as a product of those two numbers. Okay, you will get 30. Okay, so then you find the volume, which is 1/3 times 30 times 10. So it's going to be 100. And the cubic units. Okay, so this is pretty straightforward. All you have to do is find the area of the triangle at the base. Okay. All right. So next problem, we're going to work out a little bit. Okay, so this is the next problem. I have a rectangle square pyramid is placed in a cube so that the base of the pyramid and the base of the cube coincide. So the vertex of the pyramid lies on the top face of the cube. So if we know the volume of the pyramid is 72 cubic centimeters, what is the volume? What is the surface area of the cube? Okay, so this is a cube. A cube means all the sides are equal. Okay, I know the. So this is the right, yeah, the right square pyramid. A right square pyramid have the volume has the volume has a volume of 72 cubic centimeters. 72 cubic centimeters. Okay. What is surface area of the cube? Okay, and that's the easy question. But second question is much harder. What is the surface area of the pyramid? That'll be much harder. Okay, second one is, what is the surface area of the pyramid? Okay, that will be much harder. Okay, so the first problem is a little bit easier to solve. Right, you work out the first one. I'm trying to help you to work out the second one. Okay, yeah, you just drop it. You know, the top of the pyramid touch the top face of the, yeah, top face of the cube. Okay, so the key point is you have to find the edge length of the cube. Okay, find the edge length of the cube. Okay, so remember how to find the volume of the cube. 1/3, yeah, the volume of the pyramid, right? the volume of the pyramid is going to be 1/3 times area times height. And if the edge length is A, right? So the area is going to be A squared. The height is A, so it's actually 1/3 of a cube is 72, right? So from here, you get A cubed, which is 72 times 3. Now, maybe you can find A. So you should have factored out. Actually, it's a 36. 6 times 6 times 6. Okay? Because 36 times 2 is 72 times 3. So it's 6 square, 6 cubed. So clearly, A is a 6. Then the surface area of the surface area of the cube is going to be 6 times A square. You write on the formula, then 6 square, and this is actually, again, you get the same number, right? Multiply them out, it'll be 260. So the only problem is how to find the surface area of this cube, this pyramid. Yes.
The surface area of the prism is 18 times the square root of 5 plus 9.
18 times square root of 5 plus 9. So this is 6. That's a 6. Okay. Okay. Yeah. So you also know the height. Okay, you also know the height. So in order to look at this pyramid, the 4 sides are all isosceles triangle, identical. So you just need to find the area of one isosceles triangle, right? Then you can solve the problem. That's my hint. Right? So how do you do that? Well, you just need to find this x, right? If you find the x, this is called the lateral height of the triangle, right? So you find out the x, then you can find the area of that isosceles triangle. But you needed to draw addition lines in the space, right? In order to find the x, you have to draw, go down here and go down here, and then you get the right triangle in the space. All right? So now you write down the space. So here's the x. This is going to be 3. Why 3? Because that's the middle point in the center of the square. So the length, the distance is 3. The height here is still 6, right? The height is 6, right? So the height is 6 because this is a pyramid coming from the cube. All right, so now you get x using the Pythagorean series, then done. So x is going to be square root of 3 square plus 6 square. I'm going to 3 square. Don't multiply them out. 6 is a 2 square times 6 square, 2 times 3 square. So you take 3 square out. So you get 3 square root of 1 plus 4. It's a 5. So that is a quick way to simplify. So you get x. So now you get the area of the one triangular face. So the area of the triangle, right? Area of the triangle is going to be half of 6 times x. Is going to be 3 times x. So it's 9 square root of 5. Okay? And how many of them? 4. And plus the bottom side. Okay, so the surface area of the pyramid is going to be 4 times that number, right? Because you have 4 triangles plus the base. Okay, that's a total. Okay, so the difficult part is here is going to be, just find the height, find the x. So I'm going to give you a similar problems to do this. This time, the pyramid, just pyramid, okay, consists of 4 equilateral triangle. So this is a slightly different. Yeah. Okay. So here's a still a square-based pyramid. So all the sides are equal, okay? Yeah. So all the sides are equal, and this is going to be, A is going to be, let's say, assume 1, okay? And what is the volume of the pyramid? What is the volume of the pyramid? Yeah, the pyramid consists of 4 equilateral triangles. Right? They're identical. You can make a pyramid. So the pyramid is uniquely determined. It curls up at the top, right? So right? What do you have to find out first? Write down the volume formula for the pyramid. Then you know what you have to find out. Okay? Mike? Sophia, you have answer for the 1/12? Michael, do you have answer? Right? Huh? Oh. Okay. Matthew Young says 1/3. 1/3 is clearly is not right? The volume. Because the height is not going to be 1, the height of the pyramid. Okay, it's all you have to do is find the height, right? So the volume is going to be base times it's a squared times height. So a is going to be 1. So that's going to be 1/3 the height. So you have to find the height. That's all you have to find out. Okay? To find the height, I prefer to use the following triangle. This triangle is going to be right triangle, vertically staying there. Okay, so let's draw this triangle. So this is a height. This is A is going to be 1, right? And the bottom part is X. I don't know the X. Then I look at the square. How do I get an X? The square. This is a square, right? A, right? Equals 1. So where's the point? This is a center. So this part will be X. Do you agree? Yeah. So how to get X? Right? You have to draw the picture, right? X is the center to the vertex of the square, the distance. Okay, so what is X, right? And this is so special. X plus X squared. If you don't know the exact formula, X squared plus square is going to be A squared. So X squared is going to be A squared is 1.5, right? That's okay. So you don't need to find X, just put X squared there. Then on the top, X squared plus H squared equals A squared, right? By the Pythagorean theory. We don't know, but the X squared is 1/2. A squared is 1 square. So that implies H squared equals 1/2. Okay? So you find the H. Okay? H is going to be square 1/2. Then you put into the formula, volume is going to be 1/3, 1. Now you can also rationalize the denominator. This is going to be 1/2. So you can put the square root 2 here, square root 2 here. Then you will get square root 2/6. Okay, so this is the answer. Yeah, this is will be the answer. Okay, I'm going to ask you to do another problem similar to that. Okay. Okay, let's do a similar problem. So this is a square. It's going to be 1, 1, it's a square. But this time I'm going to build a right pyramid, but each side is 2. Okay, find the volume of this pyramid. Just do one more exercise if you did not catch did not get the right answer for the previous 2 problems. The base is a unit square. It's a unit square, sorry, unit square. Yes. Square root of 7/2 times 1/3. So the answer is square root of 7/2 times 1/3 is square root of 7/6. Right? Oh, square root of 7/2. Yeah, well, usually we have to rationalize the denominator. Okay. All right. Okay, so the idea is just find the height. Okay, idea is to find the height, but this time I'm going to use same idea, you know. Yeah, this is the right triangle sitting there. Okay, so this is the x, right? So x squared plus h squared equals 2 squared. It's clear. Then you have to figure out the x squared. X squared is in the unit square, right? So this will be x. Here's a 1. So x squared plus x squared is going to be 1 square. So x squared equals 1/2. Okay, you put it at. then you get 1/2 plus h squared equals 2 squared. And then you solve the problem, okay? So h squared equals 4 minus 1/2, 7/2. Then h is going to be square of 7/2. But we always rationalize the denominator. So you multiply by 2 each numerator and denominator, you get square of 14/2, okay? Yeah, we don't put the radicals in general in the denominator. Then the answer will be the volume is going to be 1/3 base area times height, and that's going to be square of 14/6. All right. All right, so let's look at another one. I have a cube. Okay, let's go back to the cube. Okay, so what I'm going to do is, this is a unit cube. Okay, so what I'm going to do is I measure it. It says this is 1/3. Okay, this is a 1/2, and this is going to be 1, 2, 3, so 1/4. Okay, this corner. I'm going to chop off this. Okay, so what is going to be the volume of this part? Find the volume of this corner. Okay. Okay. So here, this is going to be 1/4. Okay. This is going to be 2/3. That's going to be 1/2. Okay. Clear? The measurement is clear, right? Yeah. Chop off this. So you will get something. If you put on the table, then how do you draw it, right? You put on the table, and you can put them vertically or lay on the bed, right? Looks like that, right? Yeah. Okay, this side is the 1/2, 1/3, and the 3/4. This edge. Okay. Let's see, what do we got? One over what? 48. Any different answers? 1/8, Alex says. Edward says 1/32. Oops. Any different answers? Michael. I always call it that. Answer the question, please. Karen. No idea.
Oh.
Now you cannot, you see, if you put it on the table, how do you put that? This corner, right? This corner is from any angle, it's a pyramid. Okay, triangular pyramid. Base is a triangle. So you can put it vertically, right? You can also put it this way. You can put it in that form, right? So this is gonna be 3/4. That's gonna be 1/2. That's gonna be 1/3. Okay. I want to see any different answers shows up. So Edward, did you change the answer? Justin? All right, so this is a pyramid. It's cone-like solid. The base is a triangle, right triangle. So the volume is going to be 1/3 the base times height. Okay, the base is a right triangle, right? It's going to be 1/3, for example, 1/2. So area is going to be 1/3 times 1/2 and divided by 2. So you know, you don't need to multiply this out. Just this is an area. Okay, the height is 3/4. So the volume is going to be 1/3 times 2, 1/3, 1/2, and the height is 3/4. Let's simplify it. Okay, and right. So hold on, right? 1/48. So 1/48, okay, how many of us get 1/48? On this table, Essen got 1/48. Edward, the second answer is correct. All right, so this is this corner is a cone-like solid, okay? Depends on how do you put that, the base, okay? Now, technically you can, it's complicated. Technically, you put this corner on the table like this, the base, and it's still able to find the height, but it's very complicated numbers. So I'm not gonna do that, okay? So this is but if you put it in this form, the height is 3/4. Okay, the height is 3/4. Okay. Now we still have a couple more problems in this same form. All right, the next problem is, this time I'm going to use 4 identical equilateral triangle to form the pyramid. So those are the all identical. It's hard to draw, but it's formed by. It is formed by 4 identical equilateral triangle. Triangles was edge length, just say at 1, 1. Okay. So, what is the volume of this? Is this a cone or this pyramid? Was the unit edge length, all right, equals to 1. Okay. Find the volume. So I hope someday you can go to Egypt, Cairo, to visit the pyramid. The airline ticket is the same cost to China. So it's not that big difference. I visited that once. It's a nice place. You have to go there in the winter, not in the summer, Christmas, because it's too hot in the desert. Okay, it can climb up to the top in the middle of somewhere. Can spend 1 week over there. Okay, there are so many different pyramids. Yes. Square root 2/3. Double check your work. It's a square root 2 years over some integer. Over 3? I get a smaller number. A smaller number. I want to see what the edit again. Yeah. You needed to find the height, right? So let's recall. You know, for the equilateral triangles, the area is going to be square root 3/4 times 1 square, so square root 3/4. That's clear. All you have to find out is the height of the pyramid. Alex, Shen, it cannot be a fraction, simple fraction. It involves square root 3 clearly. Okay, so the question is, how do you find the height? Okay, if you draw the height from top to the center of the triangle, this time the center of the triangle, it's a triangle, the base, it's not square. So you have to solve the problem. This is the h, this is the x, this is the 1, right? So x squared plus h squared equals 1 squared. You still have to find the x. So that's my hint. Then you draw equilateral triangle. The question is, from center to here, how to find the x? Helen, you were here, right? How do you move it? No, come on, sit here. Your mom told me I have to watch you, so I have to check request. Okay, so this is a question, another geometry question, right? So how to find the distance from center to the vertex? Because if you look at the right triangle above, right? If you want to apply Pythagorean theory, you know, this problem is similar to the previous problem, but the basis is triangle, equilateral triangle. So it'd be a little bit more, slightly more difficult to find the x, the distance from the center to the vertex. Okay, if you find the x, then you get h. If you find the h, you can get a volume formula, right? Volume formula, volume is going to be 1/3 a times h. So you already find the a. Just step by step, right? So how do you find the x?
Is it square root of 3 over 4 times the square root of 2?
Oh, there is a square root 2 there? Yes? Oh.
Yeah, I can recognize it.
Oh. Yeah.
The square root of 6 over 4.
No, let's see. Okay, I don't know. How about you? You don't know. Can you find the x? Who can give me the x? X. This is from the previous section, right? From the chapter. How do you find the x? This is 30, what? Right? And how do you find the x? It's a center. from the center to. So this is because it's equilateral triangle. So you can draw 3 lines similar, right? They intersect at the center, right? And this side is being 1/2. It's clear. And how about the other one? I think you can find the x in yeah, how to find the x, right? If you have to find this one in order to find the x from this, right? Or you can get it from the area. Okay, x is actually, say, look at that. This is a special triangle, 30-degree, right? Angle. 30-degree angle, you know the relationship between these two sides. If here's x, this must be x over 2, right? That's a key point. It's not arbitrary. Okay, so that's a 30 degree. So that's the reason you have, then you can set up the, use the Pythagorean theory to this problem. Half of x squared plus 1/2 squared equals x squared, right? Then you can get x, okay? So you multiply this out, it will be x squared over 4 plus 1/4 x squared, and multiply by 4 both sides. X squared plus 1 equals 4x squared. Then x squared equals 1/3. That's all I need, okay? Then I put it on the top. Yeah, this goes to here. Okay, and you get x squared plus h squared equals 1, so 1/3 plus h squared equals 1. Then you implies h squared equals 1 minus 1/3. It's going to be 2 over 3. Okay, 2 over 3. So h is going to be square root of 2 over square root of 3. That's good. So this is, you find the h, then you're done. So the volume is going to be 1/3 a times h, right? A is what? A is the square root of 3 over 4. And now h is a square root of 2 over square root of 3. Square root of 3 canceled out. There was no square root of 6 here. Okay? It's going to be square root of 2 over 12. That's it. Curves, right? Yeah. So I think the difficult part is to go back again. The difficult part is to find the x if you know this side. Okay, that's a good question actually, right? And you apply the Pythagorean theory to to this triangle, but you have to know the other side. Since this is a 30 degree, so this half of x. Then you solve the problem. Okay? But let's look at a simple, easy problem. Okay, I'm going to put the ball inside. Okay, so ball is inscribed in a ball of volume 12 pi cubic meters is inscribed in a cube. What is the volume of the cube? Right. So you have to recall the formula for the volume of the ball, right? The volume of the ball is going to be 4 pi r cubed over 3. Right? Hmm? Michael says 72. Edward was the answer, 96. Kellen? You don't know. Hmm? You think so? 72 is correct? Right? Hmm? No? All right, we have a 72, 64, 32, 96, and 24 square of 3.
72.
Okay. So what are we going to do, right? You look at the edge length of the cube. The edge length of the cube is going to be what? It's going to be double the radius. Clear? Double the radius. Okay? Right? Because it's a ball is inscribed in the cube. That's all you need. Then you find out the volume of the cube is going to be a cube. So it's going to be 8 times r cubed, right? So you have to find r cubed. That's all you need. You don't need to find anything else. Okay? So, but the volume of the ball is given. The volume of the ball is going to be, 4 pi r cubed over 3, which is going to be, right? We already given, right? So it's going to be 12 pi cubic meters. Just from here, you solve for r. Oops. Something is wrong with my. Oh, it's disconnected or not? No? No, just, okay. So you from here, you solve for r cubed, right? R cubed is going to be 3 over 4 times 12 is going to be 9, right? So you put it there, then you get 72. I don't know what's going on. Mike, can be quiet. All right. So the volume of the cube will be 8 times 9, 72. Okay, cubic meters. Yeah, put the unit. Okay. Now, I'm going to ask you to do another problem, but this time the ball is given the radius, right? Volume is given 4 pi. The volume is going to be the volume is going to be 12 pi. Let's see. yeah, 12 pi cubic feet. Okay, so given that, and the cube is inscribed in the ball. So what is the volume of the cube? A cube is inscribed in the ball, okay, of volume 12 pi cubic feet. So what is the volume of the cube? What is the volume of the cube? Right, that's a slightly different. You know, the cube is inside the ball. Mike, work on the problem. Helen. Yeah, this is a slightly easier problem than the previous one, but you have to draw some lines in order to figure it out. Okay. All right, the cube, right? Mike, do you have answer? No. Hey, when you get a picture 3-dimensional, right? Draw the connect the points, important points. So this is a cube inside. So you draw the diagonal, right? And the diagonal actually is the diameter of the sphere. Did you see that? Then you solve the problem. Okay. That's my hint. The diagonal of the cube is going to be the diameter of the sphere, which is double of the radius. Then you can solve the problem. Kellen, welcome. Okay, you can do it. Okay, just come down and focus on it. Okay. At the very beginning of the geometry we were talking about, right? The relationship between the edge lengths of the diagonal of the cube. So if you have the answer, right? So yeah, this is R. That's R, right? Coming from the radius. And if this is A, right? This is A. This is A. What do we get? 2R is going to be square root 3 times A. Do you remember that relationship? The length of the diagonal is going to be double of the radius. It's going to be square root 3 times A. Okay. So we already know the radius of the sphere. The reason is, right, the volume of the ball is going to be 12 pi. which is a 3, which is a 4 pi r cubed divided by 3. All right. So you from here, pi cancelled out. R cubed is going to be 3 over 4 times 12, and it's going to be just 9. Sorry, it's not a good number, right? It's 9. Okay. So 9 is going to be the yeah, it's R. Anyway, we use that, right? All right. So now, how do you simplify, right? R cubed is 9. You don't need to write down R equals something. Just I know the factor. So A, look at the A, right? A is going to be 2R divided by square root of 3. So which is going to be, that's enough, right? So I cannot simplify it further. It's not, don't be in a big hurry. So the volume of the cube is going to be A cube, right? A cube means 2 over square root of 3 cube times R cube. We already find R cube. So that's why it is, 8 square root of 3 cube is 3 square root of 3, you know, and then it's 9. But you can simplify it, right? You can put the square root of 3 here, square root of 3 here, then the denominator is going to be 9. Then 9 canceled out. 8 times square root of 3 is going to be the answer. And the cubic feet. Yeah. Yeah, cubic feet. Yeah. So R cube is 9. So, but you don't need to find R here to express R, because eventually you just need the R cube in the formula for the cube, right? Because it's A cube. A is going to be 2 over square root of 3 R. All right, now I have another one. I have a cone. All right. So the cone has a radius r equals 3, and the height h is going to be 4. All right, that's easy. And then I'm going to, a ball is in square root. In the cone. Okay, can we figure out the volume of the ball? Right, all you have to do is find the radius, right? And there is a ball inscribed in this curve. Okay, now you have to draw some lines in order to understand and to find out the radius of this. Maybe you have to do some surgery to cut it, and so you can see it easily. Okay, my hint is you cut this cone into equal 2 parts. Then you look at the cross section, what you can see. Yeah, it's very important to understand the 3D geometry here, because if you really want to study engineering, okay, maybe part of it, multivariable calculus, right? Then you have to draw the pictures like that very often. Okay, understand and visualize it. Okay, so yeah, there are problems like that. So you have to be able to draw the picture and understand the relationship among those solids. Yeah, so my suggestion is you cut it into half. You open it, and what you get is just triangle, right? The cross section, and the circle is inscribed this triangle. That's what you see. Can you find the radius of circle, which is the radius of the ball? Yeah, so we back to the chapter we learned about circles. Okay, again, you know, if you did the homework, that'll be, yeah, maybe a little bit easier for you to do the problem. If you don't do the homework, then you probably cannot figure out how to find the radius of the circle inscribed in this triangle. Okay. So the height is 4, right? This side must be 5, and this side is 3. Now, can you find the radius R? There are many ways to find the radius R. Okay, this is R. One of the methods I'm going to show you is these two triangles are congruent. Okay, these two triangles are congruent, right? Because it's both are right triangles that share the one edge, and they also other side is radius r. They are equal. So clearly that gives you this is 3, right? If this is a 3, then this is going to be 2. Then we're almost done. Okay, and you already see the right triangle there. So which right triangle are you going to use for Pythagorean theory? For this is the right triangle you can use. Okay, this is the right triangle you can use. Okay, so the right triangle you can use, then how can I do that, right? I draw the right triangle. This side is R, this side is going to be 2, right? How about the other side? I have to express in terms of R before I apply the right triangle. I think you look at this height. Height is 4, right? Subtract R, you get this part. So this part is going to be 4 minus R, obvious, right? So 4 minus R. Then you're done. Okay, this triangle cannot be arbitrary. R cannot be arbitrary. It must satisfy. This is it must satisfy this is this identity. So now there are probably 10 important formulas in the world. Pythagorean theory is one of them. It's used over again, right? And for right triangles, okay? So then you can solve the problem. R squared plus 2 squared equals 4 squared minus 8R plus R squared. Okay? Then R squared canceled out. Then 8i equals 4 squared minus 2 squared. That is going to be 12. Okay, and I is going to be 12 over 8 and 3 over 2. So that is the radius of the circle, which is also the radius of the ball. Then you find the volume, right? The volume of the ball is going to be 4 pi r cubed over 3. Right? It's going to be 3 squared. It's 27 over 8. Then you have to simplify. It's going to be 9 pi over 2. So Edward, I guess you needed to spend a little bit more time on the 3D geometry. You keep giving me the wrong answers. Okay, there's no square of 3 there. Okay. Finally, let's quickly finish that. So we have called, what is the name of that? Consists of 2 pieces like that. I'm going to draw 2 identical pyramid. All the edges have the same length. All edges, the length is going to be 1 feet long. Okay. Yeah, each feature has length. It's fixed. 1, 1, 1. Okay. What is the volume? Okay, this will be our last problem today. Okay, just review, maybe we already did that before, right? It's actually the group 2 pyramid together into one. Yeah, you can create a lot of problem by yourself. You can say, I'm going to put a ball inside. What is the volume of the ball? Right? It's uniquely determined. Maybe you can figure it out, maybe you cannot, right? Sometimes it's solvable, sometimes not, right? But at least right now we want to find the volume of this crystal, right? And all the edges equal to 1, they're identical. Yes. 2 times square root 2 divided by 3. Okay. So someone gave me the answer 2 times square root 2 divided by 3. Alex. Alex got it. Square root 3. Come on, who did it? Charles did say square root 3 over 3. Square root 3 over 3, right? Right? 7 over 8. Oh, come on, the difference is wrong. Okay. All right, so what you do is just find the height of one of the pyramid, right? Yeah, remember this, right? And you can use this triangle. Okay, so the height, well, you don't know the height even, but you know the age. So this is the age, this is the x. All you have to do is just find the x, right? And this will be the x, right? And you know that x squared plus x squared equals 1, so x squared equals 1/2. We did it before, right? Then apply the Pythagorean theory to the above problems. right? H squared equals 1 minus 1/2. It's going to be 1/2. So H is going to be square 1/2. Okay. So once you get that, you can get volume of the one pyramid. It's 1/3, but you have to multiply by 2, right? So base area is square times height. And then you also have to multiply by 2 because it's double, right? Then that's going to square root 2/3.
Yes.
Yeah, it's not going to be 2 times. Square root 2/3. So Alex got the right answer. Okay, great.